Is singularity the same as infinity? To begin with, let us explain what is meant by both terms. So, infinity can be best demonstrated by dividing 1 by x, where x represents any number from 1 to some undetermined big number. For example, if we divide 1 by 5, we have a number less than 1, or 0.2. As the denominator becomes bigger and bigger, the quotient becomes smaller and smaller. As the denominator increases without bound, the quotient approaches 0. At this point, there is no known number in mathematics to represent the biggest possible value for the denominator or the smallest possible value for the quotient. If we go back to our original equation of 1 divided x, we can represent the quotient by the small letter b, so that the resulting equation is 1 divided by x equals b. Because no known number is the biggest of all counting or natural number, mathematicians represent this condition by x followed by an arrow then the symbol of infinity. The arrow means that the variable x approaches infinity. A plus sign superscript is then added to distinguish that this type of infinity is increasing in value. Or the same as saying that x increases without bound, which is what is meant by positive infinity. So here we can see that the symbol infinity is not a number. It represents the condition of increasing value without bound. On the other hand, b decreases in value opposite to that of x. This can be written as b approaches 0 as shown. Or it can be written as b approaches negative infinity, and both mean the same things. Here we see that, while x is unbounded, or there is no known number we can represent as the biggest of all counting or natural numbers, b is bounded by 0 as the smallest possible value. However, in mathematics 1 divided by 0 is undefined or not allowed. And the smallest number close to 0 is not known in mathematics up to this day. This is the reason that mathematicians used to denote this condition by saying that b approaches 0 or b approaches negative infinity. Let's go back again to our original equation of 1 divided x. Here we see that x represents the number of divisions we made on 1. And 1 represents the whole from where we made our divisions. If we consider the whole as a line segment from 0 to 1, then b represents the length of each segment that was created. We can represent this as follows. On the screen is shown a line segment which represents the whole, or in this case 1. We can see that this line segment was further divided in 7 parts. And the length of each segment is 1 over 7. And this can be represented by the equation 1 over 7, or meaning 1 is divided by 7 parts. And 1 over 7 is also equal to the length of b. Now, if we denote the whole line segment as d, and each tiny segment as a unit making up the whole, we can write 1 plus 1 plus 1 plus 1 plus 1 plus 1 plus 1 equals d. Here we see that each of the tiny segments is b, and there are 7 b's. So, we write 7 times b equals d. Since x is the total number of divisions on the line segment d, we can also write x times b equals d. And we can see that x times b is also equal to 1. Now we have represented the whole and the unit as both 1. And to distinguish between the two, we arbitrarily designate 1 representing the whole as 1 raised to the power o. And we can write d is equal to 1 raised to 0. Again, if we divide the whole by x and the value of x are as follows. When x equals 5, it means that the whole is divided into 5 parts, which can be represented arbitrarily as, or means the whole is composed of 5 parts or units. Then we can write, or when x equals infinity, then the whole is made up of infinite parts and can be represented as shown. The 3 dots means that the whole is made up of infinite units or ones. What I am trying to show you here is that at infinity, the whole is made up of infinite x or parts, which we can describe arbitrarily as granular. And, if all of these parts were added together is equal to the whole. And being granular, or made up of infinite parts is what distinguishes infinity from a singularity. At a singularity, the segment D is made up of an infinite amount of points. And points are zero-dimensional mathematical entities. And adding up an infinite amount of points is counterintuitive because the sum will just give is zero. But the sum of zero is not what is meant by singularity. If the sum is zero, then this is still in the realm of infinity. Singularity requires that the sum must be equal to the whole or 1 raised to 0. And the length of the segment D is still the same, but it is no longer granular, similar to the condition at infinity. To sum up things, at infinity, the parts making up the whole is greater than 0. The sum of the parts equals the whole. Division by 0 is not allowed. At a singularity, the parts making up the whole is 0. The sum of the parts is not equal to the whole. Division by 0 is allowed.
Fools like them, they suss me out and then they ghost. Girls like me, I like a magnet to a knife. Can like a lighter from the ocean. I sell them my devotion and show them my thoughts. Fools like them, they suss me out and then they ghost. I found a rainbow in the shade, the shades to places a better one I saw. I said, oh, I've been love somebody. Oh, can you even make it?
Imagine you have a ball. Then you shrink this ball to a point where it ceases to exist. Now imagine the whole universe. Then imagine that everything will be removed, galaxies, stars, planets, etc. Now, all that is left is an empty space. Then if we remove the space, all that is left is nothingness. It seemed that there are two types of nothingness. The one, when you shrink the ball into a point, and the other one that houses the universe. Is nothingness bigger than the universe that it houses? We can think of the bigger nothingness as made up of zero-dimensional particles. Or we can think of it as a universe of zero-dimensionality. Now, let us go back to our discussion. Can we represent the singularity as the bigger nothingness we talked about? And the points as the particles making up this singularity? And before we end this video, it should be noted that the differences between the unit 1 we discussed earlier and the whole, represented by 1 raised to power 0, can be summarized as follows. What do you think? Just leave your comments in the comments section below. And this concludes our video. If you like this video, give us a thumbs up and please subscribe to support the channel. Thanks for watching.